Hello, everyone. Welcome to 60 Minutes of Unscripted .NET Entertainment. As doctors of .NET, we prescribe healthy choices in .NET. Today, I'll be your host, Cecil Phillip, and I'm also joined by my other host, Mr. Ken Soper. And today, I'd like to welcome our guests. So we have Jose, we have Krzysztof, and also Laurent. And they're going to be talking to us about some really cool things about .NET and IoT. Now, today is a little bit different than some of our usual episodes. We're going to be doing an AMA, right? An Ask Me Anything. So if you had any questions about .NET and IoT and how it works and how to kind of plug those worlds together, now is your time to ask all the questions, right? Like now is your chance. So let's go ahead and get those questions rolling inside of the chat. And while you guys go ahead and come up with some questions, why don't we go ahead and introduce our guests? So why don't we start? Let's start in the order that it looks like on the window. So Jose, why don't we start with you? And then we'll go to Krzysztof and then Laurent next.
Sure. So hi, everybody. My name is Jose. I usually go by Joe as well. And I've been a .NET developer for about 8 or 9 years now, straight out of college. And I've been working for Microsoft ever since and been working on this very cool IoT project for about 3 years now, 3 to 4 years now. Really exciting. It is my first time that I work so closely together with the hardware. So it's been definitely challenging and amazing. So yeah, I learned a lot of things from it. And definitely now, of course, I have all of these IoT sensors playing around in my house. Yeah, I guess that's pretty much it.
All right, and Krzysztof?
Hello, so my name is Krzysztof. On GitHub, you can find me as KRWQ. I'm a dev on the .NET team and part of the .NET IoT team since almost very beginning.
Nice. And Laurent?
Yes, hi, my name is Laurent, and as you can see with my accent, I'm French. So we speak Frenglish today, Franglish or something like that. And I'm working for Microsoft in a division called Commercial Software Engineering. So I'm not part of the .NET IoT team per se, but I've been one of the main contributors since day 0 or even day -1. I've met Krzysztof and Jose even before they started to launch the site, and since then I'm part of the extended team. I'm as well part of .NET Nano Framework, which is the small brother of .NET IoT. So you can run .NET as well on ESP32, for example, or STM32 chips, and we are all working together as a large family. That's it.
Nice. And just before we start too, I always like to give a quick shout out to all of our folks in the audience. Like we always have these, amazing folks that are watching us from all over the world. I'm looking at the chat right now, and I can see that we have some folks here from South Africa, from Ukraine. I'm personally in Florida. I'm sure the rest of you folks are all different parts of the world and of the country. So, it's always just amazing for me to see like how vast like this .NET ecosystem is, and like all of these different folks creating really cool and interesting solutions. Now,
Cecil, we have our first question from the audience that I think needs an answer. Is that a cat? And I think the question is directed at Jose. It looks like there might be a cat on your bed behind you, Jose.
Not a cat. It's a 10-year-old Yorkie. Very passive. Probably like a cat. His name is Napoleon, so the name matches the size.
Nice.
Napoleon the Yorkie.
That's right.
Awesome.
That is very cool. That is very cool. And here comes the streamer. So now I see all these folks. We got Turkey, Senegal, China, Portugal, Belgium. There we go. It's just always amazing to see that stuff. Now, why don't we just go ahead and get started with like a very introductory question. I know the three of you mentioned that you work on the IoT team with .NET. And I wouldn't be surprising to me that a lot of folks don't know that you could build IoT solutions with .NET. So maybe we could talk a little bit about, like what is some of the work that you guys do day to day in the team, and what are some of the solutions and scenarios that you're trying to support? So maybe let's start with Jose. Why don't we start with you first?
Sure, I can take that one. So a little bit of the history of the repo. At the very beginnings was probably around 2018. We had an intern from Argentina called Edgardo, and so he joined the team and he worked on this project, which was exactly that. So we wanted to see how could we connect .NET developers to continue using the language that they love but now apply it into IoT, right? Because usually the answer or the language answer for that would have been either C or more of a native language, or Python, right? So we try to say how can we play in that space. So Edgardo came in, he developed this like his overall his 12-week period with us. He worked on this great library. He worked on it. We had a repo specifically for experiments like this called CoreFX Lab, and so he worked on it over there in 2018. And after he left, around basically the ends of 2018, so around October, November, we realized that there was a lot of attention here, and a lot of people were really interested in us providing this and productizing this, basically. And so around that time, we created this repo, the .NET IoT repo, and that's where we basically migrated all of his work, as well as kind of like worked on a high-level design. So we basically went through the same process that we would have done at that point, as any .NET library. So we went back and went through API design and made sure that basically what he worked on met all of the guidelines, and we made some small adjustments as well as implementation details and stuff. So that was about in October 2018, and around October 2019, so a year later, we shipped our 1.0 version. And yeah, basically the thing that we work on is basically two libraries. First library that we ship, I suppose that if you guys are interested in .NET, you know what this thing is. So it's a Raspberry Pi. So the first thing that we worked on was this library that controls, I don't know if you guys can see like this pins over here. So basically you can connect a whole bunch of devices into this. So you can connect sensors like cameras, motion sensors, temperature sensors, and basically whatever kind of sensor you wanna connect to it. And so the first library that we worked on is basically just the protocols of how you can communicate with those sensors. So it's very high level and low level communication. We basically control how you can send the ones and zeros. And then the other library that we work on is more of a higher level API. So I saw that actually in the comments. Somebody asked if we actually had this higher level, like maybe you don't want to know exactly how to communicate with a temperature sensor. You just want to get the temperature after connecting to it. So we have this higher level, we call them device bindings, which is just an abstraction that underneath it uses our first library to communicate with these devices. But you don't have to understand what the communication protocol has to be. All you do is it has methods like get temperature, and that's all you call. And yeah, so basically those are the two libraries that we work on in the repo. Yeah, I don't know if my colleagues want to add anything to that.
I think you summarized it very good, Jose. Just to give you ideas of sensors, like maybe we can show a couple of sensors. So those are, small sensors that we support, all of them. There is a large family, so you can use those directly with the high-level API, and the low-level for those who are a bit more technical. Gpio, SPI, I2C, PWM, UART. We do support all of that for the lower level. And if you don't understand that, then you can use directly those with the higher level.
So that kind of brings up an interesting question for me. Now, I am not an IoT expert. I have never built an IoT solution or deployed it or anything of the sort, but I am familiar with .NET. I know ASP.NET, and I'm familiar with things like Xamarin and Windows Forms and C# and Visual Studio. For those types of folks, what do I need to do to get started with IoT and .NET? Like, what are some of the things I need to do, or like, what are some good ways for me to kind of just start slowly, like adopting some of those things inside of the applications I'm trying to build?
What?
I can answer this one. So the really easy way to get in is either get a Raspberry Pi. That's like a very common solution, but there's also an easier solution where you don't really need any Raspberry Pi, and it also answers the question on the one of the questions in the comments I've seen, like what are the sensors you could recommend. So rather than getting a sensor first, I would recommend to get the FT4222 or some kind of development board. It looks kind of like this. So so what this allows you to do is plug. You can plug this in via USB into your like any PC. It could be like Windows 10 or it could be like any Linux machine, and you can start using sensors using through that device. So like the initialization steps will be slightly harder, but in general, like the experience is much easier. It's because you don't need to do any sort of deployment. You can just start connect it directly through USB to your device. You install a couple of drivers, and you can just go and play around with pretty much any sensors you can find. So that specific device, like it supports Gpio, it supports I2C, and I2C is pretty much covering most of the devices, and SPI as well.
So just to clarify, Krzysztof, that's essentially the Gpio header off of like a Raspberry Pi that you can plug into like a USB port and access like that type of those types of SPI and I2C and GPIO buses from
so
the PC.
I wouldn't mix it with the Raspberry Pi specifically. It's kind of like a just separate device which allows you to just add GPIO header. It's like a really tiny GPIO header, but still. And it also, which also have the I2C and the SPI capabilities. But it's not related to the Raspberry Pi.
Right.
Pi is one alternative way. It's basically a kind of a computer which already has GPIO pins, so you don't really need to do anything. But the development on the Raspberry Pi is slightly harder. It's because the device is slightly slow, and if you want to like really develop on it, you would have to either like plug in monitor or like do everything through SSH, and which like for beginners, it's sometimes it's relatively hard to start. Like if you have never like used SSH or other things, like versus like the FT4222. This is like very easy. Like you just open like Windows 10 or like whatever like other OS you're using. You plug that in and just pretty much install drivers, and you're done. You can just like open anything in Visual Studio, like run samples. Like in this specific FT42, I have like a BME 280 connected. It's like a sensor for like a temperature, humidity, and pressure. So like with like this simple setup, I have like just kind of 4 cables in here. I can read the temperature in my room right now, like just through USB, and I don't have any GPIO headers dedicated for my machine. So I find this like really cool.
So your recommendation then is like, if you want to play with these libraries, just go get one of these devices and plug it into your PC.
It's one alternative.
Gotcha.
You can start with a Raspberry Pi. You can start with the FT242. We do have as well a new one, which is very similar. It's the FT232H, and thanks to Morten for mentioning it. So those are ones you can plug on your PC. And if you prefer microprocessor units, so MCUs, like for example, you can use things like the M5 stack. So it's ESP32 based, and here you can run .NET Nano framework on it, which is a small browser of .NET IoT with similar API where you have like all those sensors as well working. So that's the 3 different options you have. And for every of them, you can deploy, you can put breakpoints, you can debug, as you are used to do when you are developing an ASP.NET application, for example. Cam, as you mentioned, you're ASP.NET developer. I think, or it was Philip, I don't remember. One of you mentioned that.
Nice.
Same experience. And
I'm looking in the chat, and there's some folks that, particularly even this question, they're asking, where can we get these sensors? Now, if I go to the .NET/IoT GitHub repo, is there like a listing of supported sensors and links to where we can acquire those? Would that be a good place for them to start?
Yeah. So,
Yes.
do you want to take it?
I can take it. Yeah. So if you go to the main page of the .NET IoT, which is github.com/.NET/IoT, and you go under, I'll wait until you do. So if you go to the source and then devices, there is a README page in the bottom. You can just scroll down, or you can open the README page. It has actually a list of all of the devices we have, and they are categorized, and some of them are duplicated specifically on the website so that you can find them easier. Like some sensors have multiple purposes, like they can be both thermometers and the barometer and other things. So in that case, they might be displayed multiple times on the list. But this kind of like, if you're searching for like a magnetometer we support, or you go different, like in example, I have BME 280, you search for whatever sensor you have on this page, and if you can find it, we most likely support it. And in this specific case, the device is, I believe, I'm not sure if it's it's actually over here on the screen, FT422, if you search for that.
Oh, he was looking for the BB280.
Yeah, I was looking for the B.
So if you search for so you can either go into the folder, or in the README itself, you can also press that. So if you go under that link, I believe it might even have, it used to have links to where to buy them, I think, even.
Yeah.
But like at least it tells you like what kind of device you can use. And other option, like you can always go on the main page of the GitHub repo and ask us on Discord. So we're always available in there. And if we're not, we can see the question and answer with some delay.
The problem right now we have with like links to where to buy the sensors is that, like, of course, most of the providers will only work in a specific region or country. So it's really hard being a project that we have. Like our community is expanded across borders, and so it's hard to provide links that work for everybody. But kind of connect this question to the previous question of like where to get started. I'd say the repo is where to get started. So like that specific device listing is basically a good place for you if you're brand new. You know .NET, but you haven't played with IoT. First thing that you can do is just go to that device listing page. Maybe you're interested in a thermometer, then go through the ones that we support. And I'm sure that you can find links for like, I mean, if you make a Google search, you can find Amazon links or many different providers where you can get those type of sensors. And for each sensor that we take in, so any sensor that you click in there should have a README that has detailed explanations of how to connect it to your board, whether it's a Raspberry Pi or a different board. We have diagrams as well, and then we have code samples for all of them using all of the API sets. So if it's a thermometer, we should have examples showcasing how to use them, how to get the temperature out of them, how to get it in Celsius, Fahrenheit, et cetera, et cetera. This is like in README. Yeah.
So Jose, I would like to posit an alternative answer to that question as to where to get started. Now, you certainly, the GitHub repo is where I got started. I would also like to recommend, we actually do have an IoT documentation center that has, like, for example, a quick start. I saw earlier there was a question. Let me see if I can find it very quick. Here it is. What is the coolest, most awesome sensor you currently have and we should buy immediately? And I'm gonna take host prerogative here and answer this one. I think it's this one right here. So if you go to the .NET IoT libraries documentation page, which let me give you that URL right there. Drop the culture string for your individual culture. The Raspberry, if you're dealing with Raspberry Pi hardware, the Sense Hat is the place to start, because that thing has 6 different sensors on there, and I've put together a quick start for you that all you have to do is plug it in, get Raspberry Pi OS running on the device, and do some configuration for the SSH service and the I2C capability, and run this script, and then you'll have a working Sense Hat that's feeding data to a console, and you'll have code that you can take apart and see what's making that work.
Yeah, I think that's actually an absolutely great example of good sensor as well to get. If you just want to play around with IoT, this is a good example. It also has the tiny like LED matrix, which is like 8x8 kind of matrix of pixels. You can draw something simple like 8x8 is not much space, but you can still kind of display like even an IP address with scrolling kind of on the screen. And it also has a joystick, so you can like if you want, you can actually implement like a tiny game, like a snake or something. So I think it's a really good example.
Nice. Now we have another interesting question coming in from YouTube. And this person is asking, what's the best way to connect IoT SOAP services to .NET IoT? And I guess, why don't we tweak that a little bit? So not even just SOAP, but how can I connect any service, right? IoT, gRPC, I don't know if that's possible, AMQP, like all these types of different ways that we have to communicate with our, these devices.
Well, do you want to take it, Laurent?
Yeah, well, I can answer that. Well, it's .NET. So anything you can run on .NET as a nugget, you just install it. Then, as we said, we have support directly for those sensors. So you can read them very easily, few lines of code, and you get temperature, you get humidity, you get pressure, you get whatever you have. And then you can connect with the rest of your APIs. It's very straightforward, very easy. And again, that's just the beauty of .NET and the fact that you install a nugget, you install a service, and you are good to go. So, and we have a couple of examples as well connected with Azure. It's very straightforward as well. So you can go ahead with that. It's very easy. There is no limitation. It's really full .NET, and so
exactly.
Awesome.
And
so
yeah,
from the
basically,
consumption side, I'm sorry.
Sorry. I was just going to say, like, the way to think about it is we're not actually running our code inside the actual sensors. Instead, everything is running on a Raspberry Pi and it's running full .NET. So anything that you can configure, any type of service that you can connect to using .NET, you'll be able to connect through a Raspberry Pi. And the Raspberry Pi is going to be communicating with the sensors. So you can think of the Raspberry Pi working as a like kind of like a communication layer that's like talking to the services, but also getting data from the sensors. So yeah, it's basically what Laurent said. Sorry.
Right. So then as a .NET developer, like I can use HTTP client, I could use SOAP services, like anything that I'm familiar with. And I'm assuming that, I'm guessing they have to be like .NET standard compliant and all these types of things. As long as it supports, the version of .NET that I'm running on, I should be fine. We should be good to go.
Exactly.
Yep. The library supports .NET Standard 2.0, as well as it has additional bindings if you target .NET 5 or .NET 6. But of course, those are just like extra devices that we can only run if we use additional API that .NET 5 provides. But most of the device bindings are targeting .NET Standard 2.0. So you should be able to work. Even like we have cases where we have devices or boards that don't even run .NET Core, so they just run like Mono, for example, like the Raspberry Pi Mini, the one that's like $10. And that one we also are able to run because we target .NET Standard, and .NET Standard is supported in Mono.
Awesome, great. And it looks like we have a question from Cam. Cam, who does cool stuff. I wonder who this guy is. What methods can you recommend to help with firewall traversal from my devices?
Well, then, I mean, you can use HTTPS, for example, if you need to go through firewalls and so on, or you can use WebSocket over HTTPS, for example. That works as well. Or all those scenarios are scenarios we are using when it comes to connecting devices to the cloud, and when you don't want to have too many issues to go through a firewall. So that's the one I can recommend. That's very typical.
So I'll be honest, I set up the question just because I wanted to start the conversation a little bit, because we have this plethora of Azure services related to IoT. We have things like IoT Hub, which it can help to connect devices across firewalls to a digital twin in the cloud, right, that you can interact with via API. I know that in my own implementation, I have what's it called? There's a Azure Service Bus hybrid something. I forget what it's called.
Is that what you're talking about?
Hybrid relay. Yeah, I think that's what it is. Where you can set up like a web API in Service Bus that relays to a web API somewhere behind a firewall somewhere. Yeah. I'm actually using that with my Smoker project that folks might know about. So that was really the conversation that I wanted to start. Is what kind of interesting little like there are, I think IoT is different than like a typical deployment of like workstations and whatever, because like they're supposed to be in generally speaking constant communication, right? Sending data, sending telemetry, sending whatever, and there's always this network problem that you have to solve. No, nobody.
Yeah. I mean, you're right. At the end of the day, if you want to try to go through a firewall, the easiest way is to reuse the HTTP ports, which are usually open, and do whatever you want in the tunneling on that. That's the reason why, WebSocket over HTTP and HTTPS is very popular in this area, because you just go through, and then, services, you're right, like Azure IoT support that perfectly. Azure IoT Hub, and in general, all the Azure IoT solutions do support that very well. I know as well competitors are doing that as well. And the reason is, you want to make it easy for people to go through any firewall on those devices. So, all good, that's working like that.
Nice. Now, it looks like we have some folks that are familiar with IoT in the chat, but also some folks that are not familiar with IoT. And so I wanted to take a moment really quick to just acknowledge some of the folks that might be a little bit more early in the stage of like just understanding what IoT is and like the purpose of it. And this particular individual from Twitch is asking, well, what can we do with IoT? So I don't know if, I'm guessing any one of us can answer that question. I don't know who wants to kind of grab it.
I'm going to
roll dice. Okay, I was going to roll dice and pick somebody.
I can do it. So the things you can do with IoTs are kind of unlimited, but like to better answer this question, .NET IoT is split into two libraries. One is system device Gpio, and the other one is IoT device bindings. So the first library, system device Gpio, is specifically giving you means to connect with the devices. It's not giving you access to any device particularly, it just gives you means to do that. So it implements protocols like Gpio, I2C, SPI, PWM. And the second library, IoT device bindings, is basic implementation for different devices, so basically a tiny library which gives you an easy way to access the device. So if you've been in the beginning of this AMA, you've seen the list of the devices in the under source devices in our repo. So that list gives you everything basically we support, and like clicking on the link, you can tell, hey, I can actually use this device very easily. Like example of that might be like a servo motor. Like if you create a servo motor class, you can basically just move the servo motor by changing a simple property, or like you can read the thermometer by just accessing a property or calling a method, like depending on the implementation. So essentially, I would say the scope of the .NET IoT specifically is like a means to read sensors and implementation of sensors. So the system device Gpio is basically like, how do you connect with the sensors, and the IoT device bindings is a specific way to do that for the specific sensors. I hope that answers the question.
Yeah, I think that was a really good answer. I know one way that I personally look at it, again, from a very novice IoT perspective, is IoT just allows me to programmatically interact with my world in a different way. So kind of like you mentioned, like being able to read things off of sensors and then have some code that like reacts to that, right? Or checking temperature gauges, or checking controlling lights and like those types of things. You know what I mean? Because we as developers, we usually think of code as like we're controlling the computer, like the thing that's in the monitor, right? Like with IoT, like I'm coming out of the monitor and I'm in the real world now, and I'm kind of playing with the garage, or waiting on Cam to finish like doing barbecue in the smoker, or like just things in the real world that don't have to do with a keyboard and a screen. That's, at least for me, like that's the kind of way that I look at it. We have some other questions that we want to get to really quick. So Jose, our friend Jose, he's here, I swear, on like every show that I go on. Shout out to Jose for always being here. And
wait. You're right. He's on every show. He's in every one of our episodes. He's in like all of yours. I gotta question whether or not the guy gets any work done, or if he just watches streams all day. I'm teasing. We love our fans, and we're glad you're here. So, our audience.
I can take this question, and I've seen other few questions regarding MCUs, right? So Arduino usually is working on MCUs, and yes, you can run .NET on MCUs, so like an ESP32, because there was the question here as well. So you can run .NET. It's not just the full .NET IoT as we show you here. It's called .NET Nano Framework. So if you go on GitHub, github.com/nano framework, then you'll get a version of .NET that you can run on a microcontroller. So not exactly the small Arduino 8-bit. It works on STM32, ESP32, NXP platform, and all others. And you have almost the same experience as with the full .NET.
So let's double click on that, Laurent. Does that have the same level of device? Like I'm going to say device support. I want to say can we use the .NET device bindings that we have?
Yes.
Really?
So, yes, you can use more than 50 of them. So that's the good news, is that we've been aligning the API between the two platforms, right? So Krzysztof mentioned Gpio, I2C, SPI. So all those are aligned. And then what we've been doing as well is that we took care about porting them. There are limitations on the .NET Nano platform. You don't have generics yet. You don't have async. But as soon as you do some code generation and code transformation, then you can port those ones. So the more than 50 of the bindings we have, so the sensors, etc., are working on a .NET Nano framework the same way we are using as well UnitsNet for the units. So everything is the same. And as a developer, you can almost copy paste the code. You just have to do a little bit of adjustment sometimes. But that's it. So in short, yes, this is the support and this is the continuity. So because running a code on a Raspberry Pi is consuming much more power than on an ESP32, for example. This is an ESP32. And you can run on a battery for 8 years, for example, .NET code with a sensor on it, while, with the same battery, you run like a few minutes only on a Raspberry Pi. Of course, you won't do the same thing. This will run all the time. The other one will spend its time sleeping. And there's been a post on the .NET show on the developer blog that you can find, where I do explain all of that and a bit of introduction on the .NET Nano platform. Nano platform.
Well, I know I've got a lot of stuff I got to get done this month because it's IoT month, and like we're putting out like a new Learn module, and we're doing like a Learn Live event later, and I'm going to update some documents. But I have right here this really cool little Arduino based. This was our Microsoft developer evangelists were selling these at some point, or somebody, I forget who was selling these, but they're what does it say here? Microsoft Azure Iot starter kit. It's a little Arduino device with like 8 sensors on there. So
Arduino, Arduino is a library like .NET,
right?
That run on different microprocessors or processor.
Right. Okay, but this is that supported processor, is it?
Yes.
I think, right. Okay.
It's an ARM Cortex. Yes.
Right. So I know what I'm doing after this month.
Exactly. Yeah. So the support for this one is almost there for .NET Nano Framework.
Cool. Nice. Now, I know you mentioned this a little bit, but in terms of the Nano framework, other than like the async await stuff, is there anything else that we cannot do, or can I just assume that most things are functional?
So keep in mind that the CLR can work on a flash of 60K and RAM of 120K. So it's very limited. Okay. But then you can add more things, more classes and more elements. in .NET Nano framework. So on ESP32, you have a meg of RAM, something like that. You can add a little bit more. You have 4 meg of flash, and you run perfectly some of our bindings. There is a Azure Iot SDK. You can connect to Azure, everything SSL. I mean, secure in terms of the connection, connect to Wi-Fi. So in those small processors, you can really run a .NET application. As a .NET developer, you won't be able to use like all those complicated patterns where you pile up a lot of things and then you don't know. I mean, you have to be much more straightforward and think about performance as well. But you can really do achieve a lot of things. And I haven't seen, anything I was not able to do with .NET Nano framework in some ways. So that's what makes it very, very cool. And again, then that offers with .NET IoT from large OS and a lot of memory to very small ones and embedded, very, very embedded.
Double clicking into that, I think I'm watching Cecil. I think he knows what question I'm going to. What? So if we can't use async and await, but can we use tasks?
You cannot use tasks, but you can use threads and you can use timers and you have cancellation tokens as well. So if you really want to use tasks, it's a matter of implementing them because they are based on that. So that should be able to be done if there is really a lot of demands for that. But usually you can go away just with simple threads and few timers if you really want. The cancellation token again is available. So if you want to cancel something, that's the pattern used. For example, in the Azure SDK, connecting to Wi-Fi and a lot of different elements like that.
That sounds like a good GitHub issue for someone to start. Like,
yeah, exactly. If someone wants to implement the task, you're very welcome.
It's probably there already.
Yeah, well, on Nano framework, yes, there may be some issues somewhere for that, but so far it's not been, very much necessary to have that.
And just to complete Laurent's answer, like, yeah, we've right now drilled very much into Nano framework, which is great that we support that. But if for whatever reason, either like your Arduino board doesn't support Nano framework, or you're not very comfortable with not being able to use tasks or async awaits or whatnot, we also have this other binding, which is still running full .NET Core on the Raspberry Pi. And so this was actually provided by one of our community members, Patrick, who's been working really, really hard to help us on this new release that's coming up, the 2.0 release. And so he worked on this binding, which basically runs on the Raspberry Pi and helps drive and control the Arduino. So it's basically a two-part software, one that it's running in the Arduino and it's running native code, and the other one that's running in the managed in full .NET Core in the Raspberry Pi. And then in there you have like full .NET Core support. And I think the actual binding is called the Arduino board, I believe. And basically what it does is it's literally that. It lets you control and drive an Arduino board for whenever you need to have like real-time access to data and stuff like that that you only get with native code. You can still do it with an Arduino, but using .NET IoT with it. So yeah, that's just to complete the answer of like other ways that you can use this in an Arduino.
Nice.
And also it's not only only working from the Raspberry Pi, it's also working from the regular PC as well.
Yes,
because the Arduinos can be connected through USB. So it's an alternative to using FT4222.
And
so basically it's probably even cheaper alternative. Like I haven't personally used it, so it's really hard to recommend me because I haven't tried it, but like apparently it works really nice.
And it's PC, Mac, or Linux. I mean, like it really works everywhere as well.
So I know for me, whenever I'm picking up a new technology, the thing that always confuses me the most is the jargon. And as much as this conversation has been amazing, I can imagine for folks that are in the chat that are not IoT familiar, that there's a lot of jargon coming through right now. So I kind of want to like do like a speed round. Can we do like a jargon speed round? And I'm just gonna like call the name of a thing, and then you just tell me what it is. Yeah, does that sound cool? Hopefully, folks in the chat will like that too. So let's do jargon speed round, right? So what is a microcontroller, and also a microcontroller versus a microprocessor?
Okay, the microcontroller is smaller than a controller than a CPU. CPU, it's a traditional processor. It just do processing and it connects with the rest of the world. In an MCU, you have of course processor, but it's usually smaller, and you have many other elements inside. So you can already do scenarios like we explained using GPIOs. GPIOs goes for general purpose input and output. That's basically the pins that Jose showed before, and that's how you communicate with the rest of the world. So CPUs have that, but in much more basic ways. I hope that answered the question.
Okay, that makes sense. What's GPIO? Because we've said that term a couple of times before.
I just said it. Purpose input and output. I said it when I showed the board here.
Okay, so that it's just another.
It's a communication protocol, very similar to all communication protocols. It's just ones and zeros.
Just ones and zeros. Okay.
Pretty low level.
In simple words, it's basically a place where you can plug in something. So it's essentially like you can connect like a single line, like a cable or anything. It can be like a like a jumping wire or something else. But basically, you connect from GPIO pin to something, or you connect something to a GPIO pin. So it's essentially a way to send one bit of information somewhere.
Okay, got it.
So and then so that's what GPIO allows you to do. So but GPIO frequently refers to a whole set of pins, not just a single one.
Okay. How much do I need to know about soldering to do IoT?
For Raspberry Pi, literally nothing. Like you don't need to solder at all. And most of the devices you can buy, they frequently already have headers, which allow you to connect the jumping wires without any soldering.
So I've been working on this for 3 years, and I've soldered twice in my life. So that probably
I've soldered more, but but you don't need to do that to start.
To add on to what Krzysztof just said a little, a lot of those sensors you can find with the pin headers pre-soldered for you. I got tired of trying to find just the ones that are pre-soldered, and I started getting the ones that were not soldered and having friends solder them for me, and that was what eventually led me to learning how to solder myself.
Nice, I like that. Okay,
but soldering is really useful, and I recommend you to try it. And it's really simple once you learn.
It's part of the fun.
Yeah, and there are really great tutorials out there on YouTube. I mean, I had like a shop class in junior high school in 7th grade and tried to learn how to solder in that class, and it was an absolute disaster, and it like printed on my brain, I can't solder. And I spent my entire adult life, looking at projects like this going, I can't do that project. I can't solder. And then I learned how to solder at like 41 years old, and just like off of a 15-minute YouTube video.
Yeah, I need to learn how to. I need to definitely check out some of those videos. So maybe Cam, if you can, that's funny. Maybe you can drop some of those links maybe inside of the chat, so folks, if they're interested in learning about soldering and those types of things, that might be fun too. Okay, another thing I want to ask about, like really quick. So some folks in the chat have been talking about Azure IoT, right? What is Azure IoT and what is a digital twin?
I know who can answer this one.
Krzysztof. I mean, I guess I could. So Azure IoT is basically a place with like all different kinds of services you can connect to the cloud. So the .NET IoT specifically doesn't have anything to do with the Azure IoT. The thing it does is it basically makes it easier for you to send data you actually want to have in the cloud. So the digital twin it's a separate kind of question a bit, but it's a set of conventions which allows you to send the data to Azure IoT Hub. And the Azure IoT Hub is kind of like a really easy way to send data into cloud and getting it back. So, but on its own, the Azure IoT Hub kind of doesn't solve any problems for you. It's more like a building block for you so that you can have a way to send data to someone else without having to create like a web server or something else. And it makes it really easy to scale it out. So like in case you want to create like a tiny service which tells you like what the temperature is in a specific room, you can create devices on the IoT Hub. And the device on the IoT Hub means slightly different thing than the device on the .NET IoT. So the device on the device in the .NET IoT is specifically like a really physical device you do something with. In case of IoT Hub, the device is basically anything which can produce a telemetry. So, which means the device in IoT Hub could be a code written in Python which sends telemetry as well. So the IoT Hub kind of separates you from like how the specific thing works, and it allows you to still collect the telemetry in a universal way. So the digital twins have a language for telling you like how is the data formatted and like what the specific device can produce. So the device, so this specific language is called DTDL. It's what did it stand for? Like I believe it's like a digital twin definition language, if I remember correctly. Anyway, that thing basically is a description of what the capabilities of the specific setup are. But like it also solves like different problems, which I am not super familiar with because they weren't like related super much to .NET IoT. But it also allows you to represent different kind of relation between different places. So like even you can describe like how is the whole building connected with all of its sensors. But like the part which I kind of mostly focused about is like how a single point kind of like how does a specific device can send and represent the data in the IoT Hub. I hope that kind of makes sense, but it's like a really broad subject for like even 1 hour if I started talking about it.
Yes.
Well, and I would just like to add on to that just a little bit. There is a Microsoft Learn module out there that is like a 30-minute Learn module, and I have the URL ready to share with everybody. There's the URL. This Microsoft Learn module walks through the different Azure IoT services and explains what they do and why you would use them. Like for most purposes, most things that everybody in here would want to deal with, like sensor data and like telling a remote device to turn on a fan or something, IoT Hub is probably what you would use for most of that. But there is just like I said earlier, a plethora of services out there in Azure for connecting IoT devices to cloud resources and sending data bidirectionally.
In other words, one of the central services here is Azure IoT Hub. We've mentioned it, and Krzysztof has mentioned it. It's something that you can connect your device, have a bidirectional communication, so you can send as well information to your device, messages, but as well call functions in that in a purely secured way from end to end. And regarding the twins, you can see that as properties. So that you can send that to your device when it connects first, but the device can as well report those properties, so you can check that everything is correct. And in very short, for the central service of Azure IoT, that's how it's working. And there is a support, of course, in .NET. That's working with .NET IoT. And as there were a lot of questions, and there are still questions on Nano Framework, yes, there is as well the same support in Nano Framework as well.
Nice. Okay, so for me, just to summarize, .NET IoT and Azure IoT have no relation, but they can work together, right?
Correct.
.NET IoT is what's running on the actual device, right? And then the Azure service is almost like a management layer that's there to help with messaging and just different management tasks that has to do with like having large scale IoT type solutions. Is that pretty much
that plus controlling more than the one single device? So like think about maybe controlling a parking garage where you have tons of sensors that are just checking if a space is available or not. It's going to be really hard if you try to manually manage each parking sensor that you have in there, especially if it's a super large garage, right? So that's where Azure IoT comes into play, and it's super powerful. It lets you control all of those guys. If you have to update the version of the application that's running in that sensor, it's going to be really hard if you try to update manually, right? So that's where Azure IoT Hub is super powerful. It lets you update everything in one stop. And so, yeah, management tasks, exactly.
Gotcha. And there was someone a few questions ago, and I've lost it, but I'm going to make sure I ask the question anyway. If I don't have a physical device, can I still play with Azure? I'm sorry, can I still play with IoT? Like, are there simulators or things of that nature that I could use on my machine to kind of learn how some of this stuff works?
That's a good question. I don't think that we have many. We have a few that could be emulated. Yes, I think we have some like temperature, like CPU temperature ones that you can definitely work on without playing with an actual physical device. Of course, the magic of it, and that like the nice thing about .NET IoT is about like the showmanship. There's nothing like showing an LED matrices that is like 36 by 36 that is saying hello world. Like there's nothing cooler than that, right? But definitely you can totally start working on samples that maybe use these types of devices like CPO temperature. I think that it would be really good, and you bring up a very good point. We should probably add something in our readmes and in our official documentation of like how to get started without a device, because I don't think we have that. But basically, getting used to and learn to and familiar with our documentation, with our readmes, so that you eventually, when you do get a device, you can faster go in and start plug and playing. We could do a better job in that documentation side of it. But yeah, unfortunately, right now, it's not super easy if you don't have like a single device, like not even a Raspberry Pi. It's not super simple to just go in and play.
Gotcha. And that's understandable. Obviously, having a device would be like the preferable experience, because then you could actually have the thing, like you could actually see how it works and actually feel it, which is a very, very different type of experience.
So for the cloud specific purposes, so like if you want to play with like IoT Hub, you don't really need sensors. Like you can literally copy paste like one of the classes we have in our repo. So you copy paste the code to remove all of the implementation except for the public APIs. And I'm not sure if everyone is familiar with what API is, but like anyway, anyway, like any public method you can see in the code, like basically replace it and just return some random number. That will be your virtual sensor, and that should be enough to start playing around with. Like I've done that myself pretty frequently. Like whenever I wanted to play with the device, but it was kind of annoying when I had to plug it in and stuff, and just for testing, like I use that a lot. Like just copy paste the code and replace like all of the internals with some random numbers. That works pretty well.
And
like, especially for the cloud. Like if you really don't plan to connect it to cloud, like literally like IoT is just producing data. So like if you wanna like get a temperature, but it's gonna be like random temperature, like you can as well not use any of the IoT stuff. You can just generate random temperature, right? So
and if this is just to add to that, like if this is the first time that you hear about IoT, you're excited, you like what you heard, my recommendation would be do get a device, try to get a Raspberry Pi. They're not expensive. They're like $35 in the US. If you can find one, I think they're harder to find nowadays. But just get a Raspberry Pi and just get a Sense Hat, the one that Cam showcased. So this is, as he explained, this is a device that has a bunch of sensors that you can start playing around with, and then just follow the docs that he provided. It is a very, very cool getting started experience where you all of a sudden, by literally maybe writing less than one line of code, you'll start like it's just basically you run a command and in the command prompt and then plug in some stuff, and then you start getting all the value of playing with IoT. So that's where I would start. I would start with the Raspberry Pi, Sense Hat, and then just follow that documentation. That would be a good place.
Nice.
Hey, Cecil, I have one question that got queued up a while ago that I want to make sure we get in while we have these experts, because there might be others with this experience. Let me see if I can. I got to scroll up for the question though, because it was a while ago. It was here we go. Can we maybe have a tutorial of how to contribute IoT devices to the device bindings library? And it sounds like this person had kind of the same experience that I had. I don't really have a computer science background, and we start talking about like bitwise operators and reading bytes and doing stuff like that, and I'm completely lost. How is there a way that Ogie and I could get started on this, and could we maybe put an issue in the backlog for creating like make your first device binding or something like that?
For sure. So we have some documentation on what device binding should look like. So what do we expect on a contribution for a device binding? But we don't have the process of like, okay, so say that you have a device, we don't have a binding for it, and you want to provide the implementation for it. Where should you start? I don't think that we have a good documentation for that. So we should definitely take that issue, log it out, and then I think it would be really nice to add something like that. Yeah, it would be very valuable.
And we have a Discord channel as well, and we had a couple of contributors with very little experience who asked us for help in the Discord channel. So we basically help them as well, give feedback early in the process, even before the PR, as well as the process, because it's not that easy. You have to clone the repo, you have to do the fork, you have to do the PR, you have to do the PR later on, etc. It can be a bit confusing. So we've been helping a lot of people like that. So we'll be very happy as well to help anyone.
So where is the Discord channel? Because that would be useful for me, and I think it would probably be useful for a lot of our viewers.
It's on the page of .NET IoT. You have like join us on Discord. I think it's even the first link or something like that.
Yeah, it's if you open the README file or just scroll down on the main page, there are like two, like even after before the title, even like there's a Discord link with 24 online. So just which above the header.
Down.
So
left.
Wait. Up and on GitHub here.
Down.
Yep.
Down.
Down. Left.
And once you start seeing the
there it
page,
is.
Yeah.
Yeah, the badge. Sorry, I wasn't looking for the badge. Awesome. That's awesome.
Nice.
Well, I am going to join that, but I'm not going to do that on screen because I'm not going to share my Discord alias.
That's funny. I think that was really great. We do have just a few minutes left, and before we leave, I think it'd be interesting if you all could talk about some of the projects that you've seen people do and create. I know I've seen Cam do his he has his public project that he does with what is that thing called again? It's
I call it Inferno, and I'm gonna pop a link to it here if anybody wants to check it out. I've talked about it enough. I've actually doing a conference talk this Friday on Inferno at KCDC here in Kansas City. And I don't know, if we still have spots open for .NET Conf, I might adapt that talk for .NET Conf. But I'm not going to talk about it anymore. Basically, I have a barbecue smoker that I wasn't happy with how it was smoking my food, so I built my own controller using a Raspberry Pi and these .NET IoT libraries.
Nice. Do the rest of you folks have any interesting project that you've been working on, or mining Bitcoin or
No, I have a sprinkler system that I've been using connected to Azure end-to-end that I can manage, and I've deployed that in all my family and friends, etc. And it's built out of .NET IoT using Azure Iot for deployment. So like Geeky as well. And of course, quite a few things running with .NET Nano Framework as well on ESP32 with solar panel, batteries in my garden, everything connected to Azure as well. A few things like that, and you can find that as well on my GitHub for sure.
Nice. Yeah, I have things running in my house as well. My wife tells it my geeky projects. So like we have a bunch of temperature sensors running in the house that could basically also control the thermostat. And then I also have some light sensors outside the blinds. So whenever it's sunny, it opens the blinds because it also controls the motor, and it closes the blinds whenever there's no light. So yeah, things like that, small things like that. I'm sure that some contributors have shared their projects, and they sound much more amazing than my home automations. But yeah, little things like
I've mostly done like a kind of swag stuff, like so like a tiny robot which drives around and with the camera and can control it from the website. Then I've done some LED matrix with some fancy art on it, and then I've had a couple of I was been playing with a tiny robotic spider as well. That didn't that's quite a bit of work actually. Other stuff I can't remember at this point, but yeah. I moved recently, so I don't really have much right now in my home.
Not yet. Well, I know the reason I asked the question is because it's one thing to learn the framework and play with code, but it's another thing to actually have inspiration to do stuff. And for us, if we could give people, oh, here are some examples of things that you could do with IoT. Oh, okay. Well, I have blinds too. I have a garage. I have a smoker. I have some of these things. Maybe I can adapt that and even try and recreate those solutions in my own way to to fit my house or the environment that I'm in. So hopefully the folks that are here, hopefully y'all have seen some inspiration from that. Hopefully you guys go ahead out and check out some of the links, the YouTube videos, the repo, all the things that folks have shared. If you have any questions, obviously you can reach out to these gentlemen on their Discord channel as well, and you could have conversations and ask questions and things of that nature. But I think that's it for the show. Thank you everyone for watching the .NET Doc Show. I know some folks have been asking about recordings and all that types of stuff. It will be available on YouTube. So, if you're on YouTube right now, it'll be on this channel. And for everyone else, head over to youtube.com/.net and you'll see all the recordings that will be there. And then also too, if you want more, definitely head over to .NETDocs.dev. So DOTNET docs.dev. And you can see all the upcoming schedules and guests and all those types of things. Now, next week, we're going to have some more folks coming on. I believe next week, we're going to have Peter Gallagher on. He's going to be talking to us about home automation with Azure Percept. So if you're interested in that, definitely make sure you're back here. Same time, same channel next week. And thank you all for joining us for .NET Docs.
Thank you.
Thank you. Bye, everyone.
Bye, everybody.
Thanks. Bye-bye.